Well, first you want to like put them down each like on both sides from your reactant and your.
Okay. So like this?
Yeah.
Do I need to separate this or should I keep them together?
Keep them together.
Okay. So on the product, on the reactant side, how many manganese do I have?
One.
On the product side, how many manganese do I have?
One.
On the reactant side, how many gold do I have?
One.
On the product side, how many do I have?
One.
On the reactant side, how many nitrates do I have?
Three.
On the product side, how many nitrates do I have?
Two.
Okay. So what do I need to do to balance it out? Or is it balanced?
No, it's not balanced.
Would you add a 2 on the reactant side next to AU?
So on the reactant side next to AU. Okay, so then that would give me 2, and that gives me 6. Is that balanced?
No.
No.
Okay.
You want to put a 3 in front of. No, actually, you want to put a 3 in front of magnesium. Sorry.
Manganese.
Yeah, on both sides.
Okay, on both sides. Okay, is that balanced?
No.
No.
And then you want to put a 2 on gold on the other side, on the product side.
Okay. Okay, so got everything balanced. Good, good, good. Okay, so tell me about the redox. Who's being reduced? Who's being oxidized? And how can I figure that out?
You have to find the oxidation numbers.
Okay, so what are the oxidation numbers and how do I find them?
Using your rules.
Okay, so I use my rules. What are my rules?
So element oxidation number, it would be 0. So manganese would be 0.
Okay. Let's see, use a different color. Okay.
And so
Okay.
AU would be 3 plus, because oxidation of an ion will be the charge on that ion.
Okay.
And so the polyatomic molecules, they have to add up to the charge on NO3. So,
Okay.
so
So NO3. What is the charge on NO3?
so
Negative.
Okay.
so oxygen is -2.
Okay.
So then that means that nitrogen will be +1.
Are you sure? How many oxygens do I have?
Oh wait, you have 3. Never mind. Would it be 5?
Okay.
Yeah.
Okay. Now what about over here?
So for manganese, it'd be 2 positive. And oxygen would be -2 also. And that would be 5.
And then my gold.
Would that one just be 0?
That's right. Okay. So manganese is going from 0 to +2.
Reduction?
Is it oxidized?
Yeah.
Oh, it's the opposite. When it's gaining, it'd be a negative, huh?
That's right.
Okay, cool.
So what about gold? Oops.
Reduced?
Okay. Piece of cake?
Sure. Yeah.
Okay. So these are kind of nice. They're real simple to kind of figure out, not too hard, right?
Yeah.
So let's see if we can give you guys a little bit of a challenge here.
Dr. Henry, are these rules?
Yes. Yes. Can you hear me?
Yeah, I'm cutting in and out. Can you hear me?
I can hear you.
Okay.
Okay, so let me take a step back so you guys, because you were probably trying to write all this down, right? Or you
Yeah.
can just print out the notes. Okay, so the first part that you want to do, you want to break it up into 2 reactions. One that you're going to pretty much know that's going to be oxidation. The other one is going to be reduction. Okay. Then you're going to balance everything in the equations except the oxygens and the hydrogens. Then you're going to balance the oxygen atoms with adding water. Then you're going to balance the hydrogen atoms by adding H+. And then the last thing you're going to do is balance your charges by adding electrons. We know the charge on an electron, what is it?
Negative.
Okay, good. So I want to be sure that we're in the right class now. Okay, so if necessary, you can multiply by coefficients, right, to try to get everything to balance out. And then also to add up the 2 equations, because you're going to add up the 2 equations so that you could get the last parts of it all balanced, okay? And then you're going to get rid of all of the species that you see on both sides, spectator. Okay? You guys got it? Now, if the equation, if you have a situation where you have a basic solution, right? So it says it's specifically a little bit basic, then in this case, you're going to add the OH, the hydroxide ion, to both sides of the equations to equal the number of H pluses. Okay, so you're going to go through that whole step, everything that you did, but now you're just going to add the OHs to equal the number of H pluses. Okay, and then on the side where you have H and H plus, then you're going to make that water. So that's going to be a water molecule. Okay, and then to simplify the equation, you're just going to basically remove all redundant water molecules, anything that's doubled. Okay, and then the last part, you'll just do and see if everything's balanced at the end. Okay, you want to give this a shot?
Sure.
Yeah.
Okay, you got the notes, right? You got it down.
Sort of.
Okay. Okay, so here's our redox equation. So we're going to write a balance equation for the reaction between dichromate ion and iron 2, yielding iron 3 and chromium 3 in an acidic solution. Okay, so what is the first thing I'm going to do?
Split them into half reactions.
You split them into two half reactions. So we're going to have this guy and that guy being one reaction. Is that going to be my redox reaction, or is that going to be my?
I think that's your oxidation.
Okay. So we could take a look at it. Let's see. What is the oxidation number on the chromium here?
Two negative.
Is it 2
Oh.
negative?
Oh no. 0.
Are you sure?
No.
We have 14 oxygens, and the oxygens are going to be what?
Oh, -2.
-2, and we have 14 of them. 7 times -2.
14.
I can write.
So 12?
Okay, so
Oh,
6.
so altogether you have 2 chromiums. Each one is
Oh.
going to be
6.
6. Okay. So if I'm going from 6 to 3, is that oxidation or reduction?
Reduction.
Gear, right? Gain of electrons. Okay, so my first reaction is going to be Cr2 O7 2 minus. Okay. So the other reaction by default is going to be
Fe2 plus.
Is it-
Oxidized.
okay, oxidation.
Yeah.
And it's going to be, you said Fe2 plus. Okay. Piece of cake so far?
So far.
Okay, so let's start off with the easier reaction. How can I fix it so these guys, this would be a correct reaction? Are there any oxygens here? Are there any hydrogens here or anything like that?
No.
No.
So what's happening? How can I go from 2 plus to 3 plus?
We add an electron to the product side.
Okay. Okay, so we're good here, right? So we just check it off temporarily. Okay, so now that upper one, that one's a little more complicated. We have these oxygens. How do we balance out those oxygens?
You use water, right?
We use water. So how many water molecules do I need?
Uh,
7.
I need 7 because we have a 7 here, right? Oh, also, let's look at this guy. What about our chromium? What do I need to do for that? How many of these do I have?
2.
So I need to make sure that that's balanced too, right?
Yeah.
Yeah.
Okay, so I need 7 waters. Okay, so then I got my 7 waters, my 7 oxygens. So what do I need to do to the other side to balance that out?
Do we add hydrogen atom or hydrogen ions next? Or
Okay. So we add hydrogen ions. How many are we going to need?
uh, 14.
14.
Okay. And so overall, the charges are going to have to be even on both sides. Are the charges even? How many positive charges do I have over here?
14.
I have 14 positive charges. And then how many negative charges do I have here?
2.
2.
Okay, so -2. So altogether I have on this side plus 12. And then on this side, this guy is neutral. This guy is, we have 2 times plus 3.
6.
So +6. Is that balanced?
Yeah.
Okay, so what do I need to add to make it balanced on both sides?
Electrons.
Electrons. How many electrons do I need?
6. Oh, my bad. On that side. Yeah. Oops.
You said 7?
No, I said 6.
You said 6. Okay. Okay, 6 electrons. How are you feeling so far? Not too bad?
Mm.
Can we try another one?
There's a lot of steps. But
Okay, so now we want the equations to be equivalent in terms of the electrons that are being transferred. So how would I handle that? So how many electrons are here?
there's 6 electrons.
There's 6 electrons.
Mhm.
How many electrons are over here? Because we want them to cancel out on both sides so we don't see them.
There's 1. Or
1. So what do I need to multiply this guy by to make it so that they're
6.
transferring the same amount? 6. So we multiply this whole equation by 6. Move it. Okay. And then all we're going to do is add up the two equations. Okay, so we have our 6C here, 14H plus CR2 plus 2CR, 3 plus 7 H2O plus 6 Fe, 3 plus plus 6E. So what spectators do we have? What is something you see exactly the same on both sides?
6E.
Electrons.
The electrons. So we're just going to cancel those guys out on both sides. Then we're going to get rid of them since I'm lazy and I ran out of room. Can you guys see the bottom of my screen?
Yeah.
Yeah.
Okay, so that's our answer.
Jeez.
And you want to confirm it, right? You want proof. Proof's in the pudding. How many hydrogens do we have?
14.
14. What about on our product side?
14.
How many oxygens do we have?
7.
On our product side?
7.
How many chromiums do we have?
2.
On the product side?
2.
2.
And how many iron do we have?
6.
6.
And that really says iron.
Hmm.
And 6. Okay. Piece of cake.
If you say,
What was that?
if you say so.
If I say so?
Now we need,
Sure, I say so.
we need more examples. More
What was that? Oh,
More
one other thing. If you check the charges on both sides, they should also add up. So I have what, 14 here?
Mhm.
And then I have, what, 12 there? And this guy is -2. So what is that? 24?
Mhm.
24 positive charges over there. 6 times 2. I mean, sorry. 2 times 3
6.
plus 6 times 3.
18.
24. Everything checks out. Are you happy? You had that look. Questions, concerns? Oh, I'm not letting people in. I'll let you ponder it. I need to take a bathroom break. Too many fluids.
Oh, I see. I see.
Okay, how was it? Are you still there? Everybody went to the bathroom break, huh? Did I lose everybody?
No.
Okay, so let's see. Let's work our way through the slides here. Get to another problem.
So for the final answer for this one, it would be just that equation, right? And
Yep.
everything else is just checking to make sure you question.
That's right.
Okay.
You're just verifying it because this here it wasn't a balanced equation initially.
Yeah.
And so we just wanted to get the balanced equation.
Okay.
Okay, so let's see. Let me pull up my book. Another one. I can't think of one off the top of my head right now. My brain is fried. I had meetings all day, starting at 7 o'clock this morning.
Jeez.
Okay, so let's do. Okay, so what is my first step?
Write them into individual halves.
Okay, so what are going to be my two halves?
So the equation that's oxidizing and the equation that's reducing.
Okay. Okay. So what is the oxidation number for this guy? Hydrogen, this is hydrogen peroxide.
The O is +1. The H is -1.
The O is +1?
Yeah,
Are you sure?
because it's a peroxide.
It's a peroxide, but is it +1 or is it -1?
Is it -1?
Yeah, it should be -1. And the H is +1. Okay, what about this oxygen here?
-2.
-2. And manganese?
7. +7.
Okay, what about this manganese?
+2.
+2. And then oxygen gas?
0.
Okay, so my half reactions are going to be, which are going to be my oxidation reaction. Let's look at that manganese. We're going from +7 to +2. Is that oxidized or is it reduced?
Reduce.
Reduced.
Okay. Okay, what about my other reaction? Who are the guys in my other reaction?
The hydroperoxide plus goes to oxygen.
Okay. And that makes sense because this guy is going from a -1 to a 0, right? Isn't that a loss of an electron?
Yes.
Okay. What's next?
Balance the equations.
Okay. I have 2 oxygens here. I have 2 oxygens here.
Need 2 hydrogens.
I need some hydrogens. Okay, how do I balance those hydrogens?
Put a 2H plus.
2H plus. Okay. And then our charges, they balanced. This has a 0 charge. This guy has now a +2 charge.
Add 2 electrons on the product side.
Okay.
Can you say that again?
Add 2 electrons to the product side.
Oh, because
what is the charge on this guy?
oh,
It has 0 charge, and then over here, by us having these 2 pluses, it gives us a +2 charge. So we need the electrons to balance it out. Okay, what about down here? So we're going from a +7 to a +2. So how are we going to balance out those
We add
oxygens?
we add electrons to the reaction to that side where you're at right now.
We're going to add electrons to this side.
Yeah.
So this is a -1 right now. This is a +2.
Add electron to the right on the product
What's
side.
that?
Add an electron to the product side.
I'm going to add electrons over here.
Yeah.
Okay. But are we forgetting to do something first? Because electrons adding is the last part of that. Is there something we need to take care of first?
We need to add some, right?
What was that?
We need to add some water.
We need to add some water. Where am I adding water to? Product or reactants?
The reactant actually.
Product.
Product.
Yeah, my bad. Product.
Product.
Check that.
Okay. How many waters am I going to add?
4.
Okay. So if I added 4 waters over there, what am I going to do to what am I going to have to do to the other side?
Add hydrogens.
Add some H pluses, right?
Yeah.
How many?
8.
8. Oh, yeah. 8.
Okay. Now, you guys are laughing. What's so funny? Did I miss something? So I have 8 pluses, and then I have 1 minus. What is the overall charge on this side?
+7.
So you have +7 on this side, and then what is the overall charge on this side?
+2.
2.
Okay, so what do we need to do to make it right?
Add 5 electrons to the reactant side.
Okay, so we got 5 electrons. So that brings us down to a +2. So both sides are balanced. What about numerically? Oxygens, are they balanced? Everything balanced, magnesium's balanced, everything's good to go, right?
Yeah.
Okay, so we can add up the 2 equations. So I
No.
have 5 electrons over here. I have 2 electrons over here. What do I need to do to sit there and make them balanced?
Multiply.
Okay, I'm going to multiply the top equation by what?
By 5.
By 5. Okay, so we'll go, that's 5, that's 5, and correct me if I made a mistake. It's been a long day. That's 10, and this is 10. I didn't mean to erase everything. Okay, what about down here, our reduction reaction?
Multiply by 2.
Multiply by 2. So 2 times. Okay, 2 times 5.
10.
2 times 8.
16.
Oops. 2 times 1.
2.
2 times 1.
2.
2.
And 2 times 4.
8.
Okay, I think we're good. Now let's add up our equations. Okay, what do we get?
Ten electrons.
10 electrons.
Plus 16 hydrogens.
What is that guy called? Permanganate, 2 permanganates. Plus
5 hydrogen peroxide.
5 hydrogen peroxides. And that's going to make or generate
2 manganese ion.
repeat that again.
2 manganese ion.
2 manganese ion. Plus
Plus 8 water molecule.
plus
Plus 5 oxygen gas. Plus 10 hydrogen ion.
plus
10 electrons.
I got a room. Let me see if I can get this to squeeze over a little bit. Okay, so how many things are spectators?
The electron.
The electrons. Okay, so we're gonna cross those guys out. Anything else?
Hydrogen ion.
Hydrogen ion. We have 16 over here, and we have 10 over here. So how many can I cross out?
You can cross out 10.
Okay.
That's 6.
Okay, so then my final equation is going to be H plus AQ plus 2 MnO or minus AQ plus 5 H2O2 AQ yields 2 Mn2 plus AQ plus, my arm's getting a little tired, 8H2O L plus 5 O2G. Not OG, O2G. Okay. Questions, concerns, cash, credit. Is it balanced? Let's go. H's. I have how many H's on this side?
16.
16. What about on this side?
16.
16. Oxygens. I have how many oxygens on this side?
18.
And on this side?
It's 18.
And magnesium. I mean, manganese, not magnesium. Manganese.
Both are 2.
So are we good? It worked out?
Yep.
Piece of cake?
A lot of steps.
A lot of steps.
Yeah, no, maybe.
Yeah, there's just a lot of steps.
Okay. Hey, and this is just the one in the acid. Wait till you get to the one in the base.
Jeez.
Can I clear and go back to lecture?
Yeah.
Are your brains fried yet? Getting close?
Yeah.
Oops. But it's like a puzzle, right?
Pretty much.
Okay.
Long puzzles.
A long puzzle. Oops. Did I get that right? Yep. Okay. Okay, so now let's take a change. So we'll go back to stoichiometry. We've talked about it a little bit. Now I'm going to introduce it to you in a little more detail, right? So you guys already know that you have to balance the equation. That's your number one rule. You want to make sure that you have a balanced equation. Now you have ways of balancing equations that are very unique, and particularly with redox reactions, right? So you also want to make sure, well, first off, you want to make sure that your chemical formulas are right. That has to be the first thing. Then you want to be able to balance the equations. You balance the equations using the coefficients, right? You don't want to change those chemical formulas or those chemical species, right? So, and at this point, you should have those parts down. Do you feel you have those parts down? Can you balance equations with your eyes closed and with one arm tied behind your back?
Yeah.
Yeah.
Okay. So now stoichiometry allows us to use those quantitative relationships, right? Once we have a balanced equation, right? So for instance, if I know how much products I'm going to need, I mean, if I know how much reactants I'm going to need, I can calculate how much of a product I can make, right?
Mhm.
Or if I know how much products or reactants I have, I can use that to calculate how much products I can make, right? So in life, how many guys cook? You
I
cook?
do sometimes.
I
You
do.
said sometimes?
Yeah.
Okay. So can you guys bake a cake?
From scratch or from blocks?
Well, we'll just say a box cake for right now. Can any of you guys bake a cake?
Yeah.
So for the record, I like strawberry cake with chocolate frosting. That's my favorite cake, just for the record. Okay. And if you throw fresh strawberries on top of it, delicious. So for those who bake cakes, just so you know. Okay. So what is the ingredients that you need to bake a box cake?
Flour.
The box cake, eggs, oil, water,
Milk.
the oven.
Sugar.
Ooh.
Okay, again, a box cake. You guys are really trying to give me diabetes and
So if you have the box cake, all you need is the egg, water, and oil.
I don't
so
bake.
I need egg, water, and oil. So I need my box cake. I need, you said eggs, water, and can we use butter? Because
Yeah.
butter tastes so good in a cake.
Yeah, it's one or the other.
Okay,
Mm.
I'm just asking.
If you don't want sugar, then no. No.
I want my arteries to clog up. I don't
No.
want to die from diabetes. You see the difference? Okay. Now I'm laughing too much. Okay, so these are my ingredients, right?
Yeah.
Okay. So am I going to add 12 eggs? A dozen?
No,
How many eggs do I typically add?
like two or
Okay.
three.
I think it's like 2, maybe.
It depends how fluffy you want it or like moist.
I like a fluffy cake. So will I add more eggs?
So you put 4.
We'll put 4. Okay. How much water do I add? A gallon? 2 gallons?
Like
Half a gallon?
like half a cup.
Half a cup?
I don't know. Let me pull out my phone. Let me go Google it.
Maybe a gallon.
I thought y'all told me you cooked. Y'all should know this, right?
I have to look at the box.
That's baking. That's different. If anything, probably 5 gallons. We'll wash out the butter.
5 gallons, it'll wash out the butter. How much butter? 2 sticks, 4 sticks, 8 sticks, 12 sticks.
Maybe a stick and a half.
So none of you guys have baked a box cake before. You lied. You guys are such liars. I thought you're like, I baked a box cake before. I baked the cake before. Everybody said they baked the cake before, yet nobody can remember anything.
I found it.
Okay.
It's 1 1/3 cup of water.
1 1/3.
You're about to have a dry cake.
That was gonna be a really dry cake, huh? Okay. How much butter or oil?
It says 2 tablespoons of vegetable oil. It doesn't say anything about butter.
So 2 tablespoons of butter would be equivalent to 2 tablespoons of vegetable oil, right?
Yeah.
So let's go ahead and throw a stick in.
There you go.
1 stick of butter. I like it buttery. The salt and the savory. I mean, the salt and sweetness. It's good. Okay. So this is our recipe. So we have a box cake, 3 eggs, 1 1/3 cup of water, and a stick of butter. Okay. And then, so if we were writing an equation, box cake, so we're going to say BC for box cake. We have 1 box cake plus 3 eggs plus 1 1/3 plus 1 stick of butter. Okay. And that's going to make our cake, 1 cake. Okay. So how many pieces of cake would a person typically eat?
What?
How many pieces of cake? Or how many people can I serve with one cake?
Depends how you
Roughly.
cut.
How big is this cake?
Depends how small you cut the pieces.
We're not gonna be cheap. Come on.
All right, so 10 inches is usually 8 to like 15. Oh wait,
Well,
12 to
this cake
15.
box serves 12.
12.
There it
Yeah.
is. 8 to
Okay.
12.
So if the cake box says 12, that's really 6. Because they cut them
That's-
really thin. Okay. So we could get 6 pieces of cake out of that, right? We have 13 people in the class. And I count like 2. So let's say 14. Right? So especially if it's a strawberry cake. Actually, I count like 4. So we might want to say 18. Okay, so if we have 18 people in the class, and we said that our cake feeds what, 6?
Yeah.
One cake, or we'll say 6 pieces of cake. Okay, so then how many box cakes am I going to need? How many eggs am I going to need? How many cups of water am I going to need? And how many sticks of butter am I going to need?
Like 3 of each. Like 3 times of all the ingredients and stuff. So like 3 boxes of cake and 9 eggs.
Okay, so we could sit there and get a ratio from that, right? So if I'm going to have a whole bunch of people over and I'm going to only make one big old mix, right? I need to make sure that I have enough. Can't I figure that out by using this equation?
Yeah.
Okay, so at the end of the day, we know how many slices do we want?
14.
So we want 18 slices of cake
Oh yeah.
or 18 pieces of cake, right? So if I wanted to calculate how many box cakes I need, so I go 18 pieces of cake. According to my equation, how many pieces of cake do I get out of this equation?
6.
6. We're going to use PC for pieces of cake. I'm lazy. So then how many box cakes will give me 6?
1.
1.
So I'm going to need how many box cakes?
3.
I'm going to need 3, right? Okay, so if I have 3 box cakes, how many eggs am I going to need? What is the ratio between eggs and box cake?
1 to 3. Or 3 to 1.
Okay, you said it was 1 box cake
3 eggs.
to 3 eggs. So I'm going to need 9 eggs. Is that right?
Yeah.
Okay. This is stoichiometry. Piece of cake. So
When
if I,
Yes.
what was that?
I was like, when it's about cake, yes.
But it's about cake. At least 6 pieces, right? So if I wanted a single piece of cake, I just want 1 piece of cake, then I calculate the ingredients that are going to be needed for that 1 piece of cake.
Yes.
Yeah.
Piece of cake. Okay. Okay, so let's go to work. Okay, so here's the same example with pancakes. I like cake better, so. Okay, so let's start working with some real chemicals, right? So cake is delicious, but we want that nitty gritty because you guys see those chemical equations and then you forget everything that you learned about proportions and stuff, right? So here we have this reaction. Nitrogen gas plus hydrogen gas yields ammonia gas. Okay, it's balanced for you. So what I want you guys to do is, can you give me the ratios, or what we call the stoichiometric factors, for different things? So let's start the stoichiometric factor between nitrogen and hydrogen gas. What is the stoichiometric ratios?
1 to 3.
So I'll have 1. If we're talking about a single molecule, we could have 1 molecule of N2 to 3 molecules of H2, right?
Yeah.
Okay. If I had dozens, so if I had 1 dozen of nitrogen gas, how many dozens would I have of hydrogen gas, or need of hydrogen gas?
Three dozen.
So 1 dozen nitrogen gas is going to be the same ratio as okay. If I have moles, what would be the ratio?
1 to 3.
1 to 3.
Still 1 to 3. 1 mole oops. Okay. That ratio is always going to be the same because it's based upon the quantity, the amount that you have of each one, right? So if we're talking about the molecules, for every 1 molecule, you'll need 3 molecules of hydrogen. If we're talking about dozens, for every 1 molecule of nitrogen, I need 3 dozen of hydrogen. If we're talking about moles, for every 1 mole of nitrogen, I need 3 moles of hydrogen. Now, the same thing can be said for ammonia. So if we're comparing the relationship between ammonia and hydrogen, the ratio is going to be what? Ammonia to hydrogen. What is going to be the ratio?
2 to 3.
2 to 3. All right. So we can say the exact same thing in that regard. Okay. Simple?
Yeah.
Okay. So here's the first question. How many moles of I2 are required to react with 0.429 moles of aluminum, according to the following equation? Okay, so what is my given?
Moles of aluminum.
What was that?
Moles of aluminum.
Moles of aluminum. Okay, so we're starting off with moles of aluminum. And we want
Moles of I2.
moles of I2. Okay, so what am I going to use to get from moles of aluminum to moles of I2?
Your moles ratio.
Okay, I'm going to use my ratio. So what is my ratio?
2 to 3.
2 to 3. So 2 on the bottom or 2 on top?
2 on the bottom.
So 2 moles. To 3 moles. Moles are going to cancel out. And we're left with
6, 4, 3.
I didn't hear anything you said, but I'm going to pretend like I did.
4, 3. 0.644.
You said 0.644?
Yeah.
Okay. Three sig figs? Is that what you're also telling me?
Yeah.
Okay. Piece of cake?
Yeah.
Okay. So here, what is the mass of sodium hydroxide NaOH would be required to produce 16 grams of antacid milk of magnesia, which is magnesium hydroxide, MgOH2, by the following equation. Okay, so what am I going to do in this situation? I'm giving grams.
Go grams to a mass or what is it?
Convert first the grams to moles.
So I want to go to moles because moles is quantity, right?
Yeah.
Grams is mass. So we want to go for our quantity so we can use that the relationship of the chemical equation, right? So we can use those ratios. Okay, so I have 16 grams. Oops, and I put 12. Okay, so how do I change grams into moles?
The molecular weight of MgOH.
Okay. And how do I calculate that? I'm rusty.
Do you divide the mole or the grams by the molecular weight?
Okay, so what would be the molecular weight? How do I calculate the molecular weight?
Add the weights of Mg and OH.
Okay, so Mg is 24.3 grams per mole. And we got how many oxygens?
2.
2.
2 oxygens. So 2 times 16, is that right?
Yeah.
So that equals 32 grams per mole. And then hydrogen, how many hydrogens do we have?
2.
2. So 2 times 1.
Yeah.
Grams per mole. And then we add them all together. running out of room, so I'll put it over here. So what is that? 50.
58.32.
Okay. Per mole. Okay, so that 58 go on the top or on the bottom? It's 58 grams per mole.
Bottom.
Bottom. And on top?
1 mole.
Okay. So I have 1 mole. And that gives me moles of magnesium hydroxide. And what was it that I wanted again? My goal,
Sodium hydroxide, mass.
I want the mass of sodium hydroxide, NaOH. Okay. So I know that magnesium hydroxide is not NaOH. Okay, how do I get there?
Mole ratio now, which is 2 to 1.
No, it's 2 to 1.
Yeah.
Okay. So for 1 mole of magnesium hydroxide, there's 2 moles of sodium hydroxide. Okay, I get it. So my magnesium hydroxide is going to cancel out. So now I have moles of sodium hydroxide. Is that what I want?
No, you want grams.
I want grams. Okay, how do I get to grams?
So 1 mole of sodium hydroxide to the grams.
Okay, say that again. I'm sorry.
We'll use 1 mole of sodium hydroxide to the mass of it.
Okay, so you said 1 mole of, now where do I get that mass stuff again? I forgot. That molar mass. Where does that come from again?
Of the elements.
Okay. Oh, so you're saying from that periodic table thing that I'm supposed to be using, right? This thing here?
Yeah.
Okay. So sodium. 23?
40. Yeah, 23.
Oxygen
16.
and hydrogen.
1.
You said 40?
Yeah.
Okay, cool. So that gives me my grams of sodium hydroxide. How many sig figs should I have?
2.
2 sig figs. Okay. $22. My age.
Yeah.
Piece of cake.
Piece of cake.
Taylor, are you there? Taylor, tell me the truth.
Hello.
Is it a piece of cake?
Yeah.
Yeah. Baltazar.
Yeah.
Yeah. What type of cake?
I don't know. I don't like cake.
You don't like cake? You're missing out. You got to try my strawberry cake. Not mine. You need somebody else to make it for you. Mine, you may die of coronary disease.
I don't like sweet stuff that much.
Ah. Okay. Is it sinking in? Good, good. Okay, so things we want to remember. If you're given grams and you're going to be using a chemical equation to try to find out something else, you always want to convert to moles. Okay? Moles is the great gateway drug. Okay?
All right.
Okay, let's see. Okay. So here is everything that you've learned at this point. Is it all sinking in? So we've talked about density. So we know if we have volume and we use density, we can calculate mass. Now from mass, if we have molar mass, we can calculate our number of moles. Now, if we have number of moles and we have the molarity, we can calculate the volume. Now let's go back to these moles here, right? We have moles and we have Avogadro's numbers. We can calculate the number of particles. Now, if I want to go from moles or let's say volume of one solution, I can use the molarity to get the number of moles of that solution. And then I can use my chemical equation to get the number of moles that need to react with that solution, or that's going to be produced by that solution. Okay? And then I can go and calculate its molarity, or calculate, use those number of moles with the molarity to calculate the volume that we need of that solution. Okay? Or I can come all the way over here and figure out the mass by using the molar mass. I can figure out the volume if I have the density, or I can figure out the number of particles. Isn't this a beautiful flow chart?
Amazing.
It's amazing, right? Amazing. Okay. How you feeling about it?
Not bad.
Yeah. So if you look on your homework assignments, right? Some of your homework assignments, me and Alexis were testing it out, right? On Monday.
Yeah.
He just wanted to make sure I knew what I was talking about. And in that situation, we were given volume and molarity. So the first thing that you want to do is, well, the very first thing that you want to do is balance your chemical equation, right? Make sure you have your chemicals written down first, balance your chemical equation. The next thing that you want to do is change to moles, right? Then you use your molar ratio or your stoichiometric factor, your mole to mole ratio, to determine the number of moles of your other solution that you're looking for. And if you have the number of moles and the molarity, you can calculate the volume that you need to add to completely react with that compound. Piece of cake?
Mm-hmm.
Yep.
Okay. Okay, so let's add a little bit of complexity. I know we need to stop, huh? I want to keep going. I'm anxious. We're so close to finishing chapter 4. We're not, but I like to pretend that we are. 109 slides. I need to trim this chapter by crazy. Okay, I'm going to go over it anyway. It'll take me a minute. Okay, so I like cheese sandwiches. You guys like grilled cheese? With all the butter? Mine, butter. Put some butter on it.
Yeah.
Delish, right?
Type better.
Love it. Okay. So now, if a grilled cheese sandwich is made up of, we're using one big old slice of cheese, because I don't like the little slices of cheese. I like the really double size, triple size. Okay. 2 slices of bread, and that's going to give me 1 sandwich. Okay. So if I have 28 slices of bread and I have 11 slices of cheese, how many sandwiches can I make? Now the ratio again is 1 slice of cheese to 2 slices of bread. Let's see. Natalie, you've been quiet. Are you there, Natalie?
Yes.
Okay. So if I have 28 slices of bread and 11 slices of cheese, how many sandwiches can I make?
11.
11. Why 11? Why can't I make 24? I mean, 14.
Because when you have 11 slices of cheese.
Because I only have 11 slices of cheese, right? And without cheese, it's not a grilled cheese sandwich, is it?
Mm-hmm.
Okay. So under those circumstances, right, the cheese is the limiting reactant or the limiting reagent. Okay. So that means that we can only make enough grilled cheese sandwiches of the amount of cheeses that we have, right? We only have 11. Make sense? Now, this applies to chemistry, believe it or not. It just doesn't only apply to cooking, right? So we would define the bread as being excess, cheese limiting, okay? And this is just showing you that, right? Okay, so we can apply this to chemistry. So if we're going to consider a chemical process, H2Cl2 yields H2Cl, right? So if we have 3 moles of H2 and 2 moles of Cl, which one is going to be limiting? Now the ratio is 1 to 1.
Chlorine.
Chlorine is going to be limiting. Who's going to be in excess?
Hydrogen.
Do you see it? Okay, piece of cake. So there's a couple of ways that we could sit there and do this. I mean, of course, we could just look at it right now and tell, right? But the other way is just by using the mole to mole ratio, right? If I have if I have 3 hydrogens, 3 moles of hydrogen, I use my molar ratio. What is my molar ratio between hydrogen and chlorine?
3 to 2.
It's 3 to 2, right? I mean, sorry, is it 3 to 2?
Oh, that one?
Based upon my chemical equation, yes.
1 to 2. 1 to 1.
Okay.
It's like 1 to 1.
It's 1 to 1. 1 mole of hydrogen, gas, to 1 mole of chlorine, gas. So that means I'm going to need 3 moles of chlorine to react with all of the hydrogen. But I only have 2 moles. So that just confirms that, guess what? Chlorine is limiting. So I'm never going to get 3 moles I'm never going to use up all 3 moles of the hydrogen gas, right? Or I could have went the other way, right? I could have started with the chlorine and figured out how much hydrogen am I actually going to need to react. Or I could have done something crazy and did both of them, right? I can do that on the hydrogen and the chlorine and figure out how much of my HCl I'm going to have. And one is going to be more than the other. And then I know that the one that gives me the less value is limiting. So there's 3 different approaches that I can get to the same answer. Okay? How you doing? Okay, good. Raphael is starting to pull out his hair a little bit, you know. I was seeing that. He's like, I don't want anybody to be bald by the time they finish chemistry, you know. Dr. Henry made me go bald. He didn't even use chemicals. He just talked all the time.
We're getting there.
Okay, so I think this is a good breaking point.